Okay, so what we're seeing here is kind of a desiccated sheep eye. You can see this is the anterior side here, right? So this is the front of the eye right here. And even though it's preserved and the cornea is not as clear as it should be, we can definitely tell that the cornea is very different from the surrounding sclera, right? So the sclera is the white of the eye that we see right here. Here's the cornea. Now all the rest that we see out here is actually going to be some paraocular fat as well as some of the muscles. So when we see it brown, kind of like this and like this is some of our like extrinsic muscles that we see here attached to the surface of the eye. And then this is some of the fat that surrounds the eye when it's in the eye socket, right? So it's got some cushion to it. Now we rotate to the posterior part of the eye. Again, we see a brown muscle and kind of a yellow fat like that. But notice as we kind of separate it, you can see that there's a little stalk sticking up right there. So that little stem that we see right there is the optic nerve coming out the back of the eye, right there. So that's the optic nerve. So what we're going to do is we are going to take a look into the eye itself. We're going to do like a coronal section around here so that we can separate the anterior from the posterior part of the eye. Now you could do it with a scalpel, you can do it with your scissors like that, but realize, remember, both the anterior and the posterior cavity of the eye have fluid in them. So as we're doing this, we're going to see some fluid coming out. So you could start, if you want, by doing like a poke. You could do a little slice along it. I try not to get my head into it. So you can see a little bit of fluid just came out. And it's kind of leaking down there like that. You don't ever want to see this in a real living eye for sure. So you can cut all the way around like that. You could also, like I said, do it with your scissors if you wanted to, if you want to make sure you weren't going as deeply into the eye. Let's see if quite make it all the way around. So I'm going to do a little extra little whoop there. And all will be revealed. Ah, here's looking at you, right? So what we're seeing right there, what do we think that egg-looking structure is right there? Any ideas? Like, I don't know. I didn't know we had egg in the eye. Sounds like a problem. So what that is, that's the lens right there. Now some of this that we see here, the darker structure, is part of like a little bit of the choroid as well, a little bit of the ciliary body. So if you take a look here, all right, there, in the center right here, hard to pull open. Let me see if I get a little traction to it. But there is the flip side of the cornea. So that's the pupil, right? So the cornea was on this side that we saw. Light's going to pass through the cornea. It's going to go through the opening in the iris, which is called the pupil. So there we can see the pupil right there. This is the posterior side of the iris, this dark area here. So if you trim that off, you would see the brown iris underneath. So commonly, we'll see it as brown. But all of this surrounding here is going to be that ciliary body, right? So the muscles that have an attachment then and little strings that are end up going and attaching to the lens, which we see over here. So that's part of what we're seeing right in here. So when we get back over here, we can see not only the lens, but we can see some of this gelatinous substance here as well, right? So that is part of the vitreous humor that's still attached, but this is the lens. And the lens is kind of hard. You can see how it's kind of round as well, but it should be flexible. So in order to accommodate, in order to focus, that lens is going to be pulled on by the suspensory ligaments and the surrounding ciliary body, but it should be flexible so it can get thinner and thicker. But with the preservative, it ends up being kind of hard like that. If you view it from the side, you can see that there's a little bit, it's a little bit more narrow in this axis right there. So if you're pulling along that line, you see that line there? That's where those suspensory ligaments were connected. So there's part of our vitreous humor that we see there. And now we look at the posterior part of the eye, and we're going to find that there's a very delicate, thin, light brown membrane, which is going to be the retina, right? The innermost layer of the eye. So as I touch here, you can see how that little thin membrane is kind of coming away and revealing that kind of pretty blue layer underneath. But this light brown layer that's coming up like that, that is the retina. So that's where our rods and cones are on this innermost layer of the eye. That's the projector screen, right? So where images are going to be projected. So that little bit that I've scraped away there is going to be the retina. And you'll notice, see how it's attached right here? So I'm kind of pushing this around and it still is attached at this point right there. That is the optic disc. So all of those, right? So we have photoreceptors, we got bipolar cells, and then we have ganglion cells. All these ganglion cells are sending their axons through that optic disc to go out through the optic nerve, which is on the posterior part of the eye. So that's why it remains attached right there. You have all these wires essentially that are kind of leading the eye right there. Okay, so that's the retina. We kind of scraped in like that, and now we see this. Now this is a layer, there is a choroid layer in here, blood vessels as well, before we get to our sclera, the white of the eye. But this layer right here, this blue layer, is unique. We don't have this layer. This is called the tapetum. It's spelled tapetum, T-A-P-E-T-U-M, and that's it. So the tapetum is a reflective layer that's underneath the retina. And it is found in a lot of mammals that end up being out at night, and it gives them the eye shine that you may see. So if you're driving along, you see a cat's eyes, dog's eyes, deer, anything like that, it's because as the light's going in, it's going through our different cavities of the eye, it's going through in the retina, but then it's bouncing off of this reflective layer called the tapetum, and then it's coming out again. And that gives you the eye shine. And it's only when the light is directly going in through the pupil and then bouncing off of this reflective layer. And the whole reason it's there is that under low light conditions, you're only getting a few photons, right? And these animals, they don't have lights, right? And so they need to be able to gather whatever light information they can. And so as the light goes in, it stimulates the photoreceptors in the retina, and then it hits the tapetum and it comes back out again. So we're getting two chances of stimulating those photoreceptors, once on the way in and once on the way out when it gets reflected off of that tapetum layer. And so that is why it's there, is it adds extra stimulus to our low light receptors like our rods.
So in nocturnal animals, is it a different function or is it stronger, or do they have, what's the structural difference for animals?
So, with those animals, if you're talking like whatever, skunk and possum and stuff like that, as far as I know, the tapetum there is going to be the same.
Okay.
I don't know, the relative distribution number of rods that they have in their retina probably is different if they're a truly nocturnal animal as opposed to diurnal that's going to be mostly active during the day, but then at these low light periods as well. So you may see some changes there, but the layer, the reflective layer, the tapetum is going to be there regardless. Now, sometimes you may see, red eye for us, like if you're taking photos and things like that, but it's not going to be from a tapetum. That's because as the light goes into our eyes, and again, it's only very bright light that's going straight into our eyes, goes through the pupil, through that posterior cavity, goes through the retina, and it's bouncing off of our choroid layer with the blood vessels. And so that's why it appears red. So with a red eye in photos or whatever, that only is going to happen when you're looking right at the camera where the flash is right next to the camera, right? So if you don't want to have to correct that later, if somebody looks just slightly off from the camera, not like gazing off like some sort of a photo shoot, but slightly off from the camera, then the light rays won't bounce directly back to the camera itself, and you won't get that red eye. So anyway, so that's the tapetum, the reflective layer that we see there. So it's just kind of interesting to see. Okay? All right, so that's what we wanted to see in terms of the structures of the sheep eye. Mostly the same as us, but then we have that unique tapetum reflective layer as well.